All right, welcome back. I think I paused the video and then somehow forgot to unpause it and then started doing all the math. And I went ahead and did a handful of problems and then looked up and saw that the video was paused. So I'm going to go back and try this again. So what we're on now is problem 22. This section, they want you to use the discriminant to identify the number and type of solutions for each equation. Basically, use the discriminant to see how many x-intercepts you have. There's three situations. You can have, once you calculate the discriminant, it can equal a positive number, and that will give you 2 x-intercepts. Once you calculate the discriminant, if it equals 0, that'll give you 1 x-intercept. And then again, calculate the discriminant. If it's a negative number, that means that there's no x-intercepts. It doesn't touch the x-axis. So instead of just walking you back through the ones that I just wrote, I'm going to redo them just so you can follow along and see what I'm doing step by step. So for 22, again, we are not using the entire quadratic formula. We are just using the discriminant, basically the part that's highlighted in yellow. So for number 22, we're just going to use A, B, and C in that part right there. So for 22, the first thing you want to do is identify what A, B, and C are. Looks like A is 25, B is negative 20, and C is 4. So again, just using the discriminant, we're going to plug it into b squared, so that's negative 20 squared, minus 4 times 25 times 4. All right, don't use the entire formula, just the discriminant. This is what tells us, that highlighted part is what tells us how many x-intercepts we have. So negative 20 squared, that is just 400, minus 4 times 25, that's 100. 100 times 4 is 400. So in this case, 400 minus 400 equals 0. So our discriminant, once we plug in A, B, and C, equals 0. If you go back to page 112, I think it was at the bottom of page 112, that's where it tells you those three situations I talked about at the beginning of the video. So because our discriminant is 0, that means that we have 1 x-intercept. It only touches the axis once. So an example of something like that would be, I don't know, let's say that our x-intercept is at negative 5. It would look something like that. It only touches, just the vertex touches that x-axis. 23, x squared plus 7x plus 11 equals 0. Again, identify what A, B, and C are. A is just the number in front of x squared. B is the number in front of x, and then C is 11, the constant at the end. So again, using that discriminant, plug in the information. So it's going to be b squared minus 4 times A times C. 7 squared is 49. 4 times 1 is 4. 4 times 11 is 44. So 49 minus 44 is 5. I don't really care that the number is 5. The only thing I'm really looking for is that that discriminant equals a positive number. So 5 doesn't really tell me anything, but the fact that it's positive tells me that this has 2 x-intercepts. So again, if I graph this problem, it might look something like that. Cross the x-axis twice. 24, 3x squared minus 8x minus 10. All right, so it looks like A is 3, B is negative 8, C is negative 10. So to plug that into my discriminant, it's going to be b squared minus 4 times A times C. Negative 8 squared is 64. Negative 4 times 3 is negative 12. Negative 12 times negative 10 is positive 120. Again, I don't really have to calculate this. I know that a positive number times a positive number plus a positive number gives me a positive number. That's the only information that's really useful here. So since that number is positive, it's going to have 2 x-intercepts. You know, 64 plus 120, that's 184. The number doesn't give me much information, but the fact that it's positive is what's telling me that there's 2 x-intercepts. 25, 2x squared plus 9x plus 14. So for 25, A is 2, B is 9, C is 14. Let me just verify, 2, 9, and 14. So it's going to be B squared minus 4 times A times C. 9 squared is 81. Negative 4 times 2, that's negative 8. Negative 8 times 14 is negative 80, 32, negative 112, I believe. So 81 minus 112, again, using this idea that the number is positive, 0, or negative, that's the only thing we're concerned about. 81 minus 112 is definitely a negative number. So this would have no x-intercepts. So a situation like this might look like this. There's my parabola. Notice that that doesn't ever touch the x-axis. The vertex is above the x-axis. The parabola goes up in both directions. It never actually touches the x-axis. So there are no x-intercepts because that discriminant is negative. All right. For 26, when will the ball hit the ground? So Dion throws a ball into the air. The height h of the ball in meters at time t seconds is modeled by the function h of t. You can, again, reference example 4, and that'll kind of help you through this. But when will it hit the ground? That's basically saying, when will your parabola, when will your quadratic equal 0? So our quadratic is negative 5t squared plus t plus 4. Negative 5t squared plus t plus 4. Why am I setting it equal to 0? Again, if I throw a ball into the air, when is it going to hit the ground? Well, after it's 0 feet off the ground, right? So that's why we're plugging in 0, what that equation's equal to, because we want to know when it's actually going to hit the ground. So when the distance between the ball and the ground is 0 feet. Now I just have a quadratic. I can factor it like normal. Again, you could use quadratic formula. You can use slide, divide, bottoms up, factor by grouping, whatever factoring method you want to use. Since this whole lesson is all about quadratic formula, we'll go ahead and use that. So A is negative 5, B is 1, C is 4. So it's x equals the opposite of B plus or minus the square root of B squared. Here's that part where I'm not going to write every single step. I'll do a little bit in my head. So B squared, 1 squared is just 1, minus 4 times A times C. And that entire side of that equation is all divided by 2 times A. A is negative 5, so 2 times negative 5 is negative 10. So I simplified a little bit as I went, but not too much. Again, when you start doing too much in your head, you'll start making mistakes. So don't try to just simplify the discriminant completely in your head. It might be just a little too much. So my next step is to go ahead and simplify the discriminant. I'm going to keep it underneath the square root. I'm not going to try to do too many steps at once. So 1 minus negative 4 times negative 5, that's positive 20. 20 times 4 is 80, so it's technically 1 plus 80. I can simplify that. 1 plus 80 is 81. And since 81 is a perfect square, remember the idea of a perfect square is anytime I take something and multiply it by itself, that'll give me a perfect square. So how do I know that 81 is a perfect square? Because 9 times itself is 81. So I can take my calculator and type that in. What's the square root of 81? It's going to be 9. And this is where I kind of go in 2 different directions. The first direction is going to be negative 1 plus 9 divided by negative 10. The second direction is going to be negative 1 minus 9 divided by negative 10. So one direction is adding 9, one direction is subtracting 9. Negative 1 plus 9 is 8. 8 divided by negative 10 is negative 8 tenths, but I can reduce negative 8 tenths. That's the same thing as negative 4 fifths. And then -1 minus 9, that's -10. -10 divided by -10 is 1. So in terms of this problem, this is one of those types of problems where it's asking you kind of a real world situation. If I throw the ball in the ground, when is it going to hit the ground? Or I'm sorry, if I throw the ball into the air, when is it going to hit the ground? Well, if I think about it in terms of -4/5, so after -4/5 of a second, it doesn't really make sense, right? I can't really throw something back in time and it's going to hit the ground. But the other answer is after 1 second, it's going to hit the ground. It's going to equal 0. And if they just gave you this quadratic with no context behind it, yes, these would be my two solutions. If I needed to graph it, these are my two x-intercepts. But if they're asking for an answer, if I throw the ball into the air, when's it going to hit the ground? We would basically exclude that answer of -4/5, because again, you can't go back in time and throw something in the air. The only answer that would be acceptable in this situation would be this other answer, +1. So after 1 second. 27, when will the ball reach a height of 5 meters? So this is, I think it was example 4. That's the one they're referencing up here. When will it reach a height of 5 meters? So that's when you're taking that discriminant, you're setting it equal to 5 because you want to know when it's going to hit 5 meters. And depending on what the value of that discriminant is, it's going to be either possible or not possible. So let's look at this problem again. So we're on 27. Looks like A is -5, B is 1, C is 4. The discriminant is going to be B squared minus 4 times A times C. Again, I know we kind of already calculated this. This was in question 26, but we'll just do it again. So we want to see when our discriminant is going to equal, oops, let me back up a little bit. Pause for a second. I just realized I forgot to do a step. So here's my parabola, -5t squared plus t plus 4. I want to see when it equals 5. So this is the part where we're setting it up, and then we'll input our A, B, and C. So when is this parabola going to equal 5? When will it be 5 feet off the ground, 5 meters off the ground? So I have to set this equal to 0. Now I'm set up and ready to go. Because back here, this is when it was still equal to 5. I can't factor a quadratic when it's not equal to 0. So now we're good. So A is -5, B is 1, C is -1. So here we go. If I calculate my discriminant, it's going to be B squared minus 4 times A times C. When we do the math, 1 squared is 1. -4 times -5 is 20. 20 times -1 is -20. So again, this value of -19 doesn't really mean much. This is the part that's important. Since that discriminant is negative, that means that this will not happen. Whatever the situation they're asking you to do, it does not exist. It won't happen. So this ball, when you throw it into the air, it will never reach 5 meters off the ground. Okay. We're doing 28. Yep. So use any method to solve the equation. So here is just where they're trying to link past practices like factoring, using slide, divide, bottoms up, box and cross, guess and check, any method out there, right? Factor by grouping, anything. Or quadratic formula. So it's up to you. So maybe we'll do 1 or 2 with quadratic formula, and then I'll do 1 or 2 with slide, divide, bottoms up. So 28 is 4x squared plus 7x minus 11. And since this big idea of this section is quadratic formula, that's what we'll use. So it's going to be x equals the opposite of b. So in this case, b is +7, so the opposite is -7. Plus or minus the square root of b squared. I can go ahead and do this in my head. 7 squared is just 49. Minus 4 times a times c. I don't get super crazy with this. The only thing I do in my head is b squared. I don't try to multiply this out and do that in my head at the same time. That's just too much to keep track of. divided by 2 times a. A is 4, so 2 times 4 is 8. Now I'll start piecing it together. So the first thing I'll do is calculate my discriminant. Negative 4 times 4 is negative 16. Negative 16 times negative 11. That's going to be negative 16 times negative 11. That's going to be a positive 160, 176. 49 plus 176. That's going to be 200. All right, let me think about this. 210, 225. And something's telling me 225 should be a perfect square. Give me a second. I got to go find my calculator. All right. So the square root of 225. I'm on my calculator. Square root of 225 is 15. So what I have here is negative 7 plus or minus 15 divided by 8. Again, I know I've emphasized this before, but I see this every year. For some reason, people say, well, the square root of 225 is the square root of 15. They keep that root sign when they do that. The square root, when you take the root of something, it's an operation. So once you take the square root of 225, that square root sign is gone. The answer is just 15, not the square root of 15. Here's where you take kind of two separate roads. One of them is going to be negative 7 plus 15 over 8. The other one is going to be negative 7 minus 15 over 8. Negative 7 plus 15 is 8. 8 divided by 8 is 1. Negative 7 minus 15, that's negative 22. Negative 22 divided by 8 can be simplified to negative 11 fourths. Whoa. So my two x-intercepts here with number 28 is going to cross the x-axis at 1 and at negative 11 fourths. So would that be 2 3/4, 2.75, something like that? So for 29, make sure we're doing that one. Yep, that's one of the ones we're doing. So for number 29, let's see what we've got. X squared plus 4x plus 4 equals 100. X squared plus 4x plus 4 equals 100. The big idea here, what they're kind of trying to test you on, is that you can't solve this quadratic. You can't factor this quadratic using any method until this is equal to 0. So you've got to make this equal to 0 first. So I'll subtract 100 from both sides. Now I can use whatever method I want. I don't know. Let's go ahead and use the slide divide bottoms up. So A is 1, B is 4, C is negative 96. So A times C goes at the top, B goes down below. And here's the part where I'm kind of thinking to myself, and again, if you're pretty solid with your multiplication facts, this should be not too bad for you. I'm going to pretend like I'm not solid and I don't know what those two numbers are. So I'm going to show you what you should be doing if you don't know that. Again, I need two numbers that multiply to negative 96, and the same two numbers have to add to 4. Well, I know that 1 times 96, don't worry about the negatives because we can always add the negative to one or both of the numbers, but just try to find two numbers that actually multiply to negative 96, but they're way too far apart to add to 4. It doesn't matter if I have -1 or negative 96, or if they're both negative or they're both positive, they're just way too far apart. So I need to keep going. I need to find two numbers that are closer together. They're only 4 things apart. So I know that 2 times 48, that's 96, but again, still too far apart. 3 should work. 3 times 32, still too far apart. 4 should work. 4 times 24. Again, I need something, when I add them together, they're only 4 units apart. Those are like 20 units apart. 5 won't work. 6 should work. 6 times 16. So those two numbers are 10 units apart. I need something that's 4. 7 doesn't work. 8 should work. I think we've got it. 8 and 12, those are 4 units apart. Now I just have to think, well, what one has to be negative? If I need these two to multiply to negative 96, either one could be negative. It could be a negative 8 or a negative 12. But they have to add to positive 4. So the only way I can manipulate those two numbers to where they add to positive 4 is if 8's negative, right? Negative 8 plus 12 is positive 4. Negative 8 times 12 is negative 96. So if your math facts are a little bit weak, or you're just tired, or you just don't feel like it, you've had a long day, sometimes it's kind of hard to do those mental gymnastics to come up with those two factors. Just list them out. It's a lot easier. Take a calculator. Take 96, divide it by 2, divide it by 3, divide it by 4, right? And come up with those list of numbers. Divide it by 5 and it won't work. It'll be a decimal. So skip 5, divide it by 6, divide it by 8. And you can come up with that list and generate that list for yourself. So slide divide bottoms up, we always have to go back and divide by A and reduce. If I divide by 1, it's still going to be negative 8 and 12. So for my two answers here, it's always going to be the opposite. So this is a negative 8, so it's going to be x equals positive 8. This is a positive 12, so it's going to be x equals negative 12. Which one is easier? You know, I think I said earlier in another video, it just kind of depends. Some people's brains work differently. Some people don't mind this kind of mental gymnastics. You could see, I think with number 29, it actually looks maybe like less ink. But number 28, it's very straightforward. You're just plugging and playing. You're plugging in A, B, and C. You're doing it step by step. It's a little more methodical. 29 just kind of has a little bit more of a general idea that you have to come up with two numbers. It's really up to you. Even if they said, hey, use quadratic formula, you could still use slide divide bottoms up or guess and check or whatever to come up with those x-intercepts. Number 30, 3x squared plus x. 3x squared plus x plus 7 equals x squared plus 10. So exactly like that last problem, I can't factor this until it's equal to 0. So in this case, I'm going to subtract x squared from both sides. I'll subtract 10 from both sides. When I'm doing this, I try to line up these like terms. Notice I'm lining up my constants because I can't subtract 10 from x. Those are unlike terms. I'm subtracting the x squared from my x squared term, right? I can't subtract x squared from 7. So if you're not sure what I'm talking about, if you don't remember that back from Algebra 1, go and watch a video on adding and subtracting like terms. In order for this to happen, I have to subtract or add terms that have the same variable with the same power. So I can only add and subtract x's to other x's. I can only add and subtract x squareds to other x squareds, okay? So I've got 2x squared plus x minus 3 equals 0. We'll jump back to the quadratic formula. So it's going to be x equals the opposite of b plus or minus the square root of b squared. I just did that in my head. So b is 1. So 1 squared is just 1. Minus 4 times a times c. And that's all divided by 2 times a, which is 4. Negative 4 times 2 is negative 8. Negative 8 times negative 3, that's positive 24. So I have 1 plus 24. 1 plus 24 is 25. And then 25 is a perfect square, right? You can type that in your calculator, figure it out, or just think about it. A perfect square is anytime you take a number and multiply it by itself. So 5 times 5 is 25. So I can break that down to negative 1 plus or minus 5 divided by 4. And then I've got two directions. One of them is negative 1 plus 5 divided by 4. The other one is negative 1 minus 5 divided by 4. Negative 1 plus 5 is 4. 4 divided by 4 is 1. So there's one of my x-intercepts. Negative 1 minus 5 is negative 6. Negative 6 divided by 4 is just negative 6/4. But I can reduce that down to -3/2. So there are my two x-intercepts. 31, it looks like we're skipping because 31 is deals with imaginary numbers. So we're not going to look at that. I think we're going to do the rest though. 32, 30, yep. So we'll do 32 through 34. Find the values of k that will cause the equation to have the given number and type of a solution. So this is where we're using that idea of the discriminant, b squared minus 4ac. We're setting everything up, and then we're just going to solve for that missing value, okay? So for this problem, 5x squared plus kx, so you'll notice that your b value is missing, plus 5 equals 0, and the rule that they got is they want one real solution. Go back to page 112 if you forgot what that means. That means that that discriminant has to equal 0. When your discriminant equals 0, you have one real solution. So for number 32, it looks like a is 5. Our b value is just, we don't know. And then c is 5. So for 32, right? Looks like a is 5, b is k, because that's, I think, the variable they're using there, and then c is 5. So for our discriminant, they want one real solution, so that means that that discriminant has to be equal to 0. So it's going to be b squared minus 4 times a times c, and we want that to be equal to 0. What we're doing here is we're setting ourselves up with a missing number, a missing term, and we're going to solve for k. So k squared is just k squared. -4 times 5 is -20. -20 times 5 is -100. If I solve for k, the first step is to add 100 to both sides. And then I'll take the square root of both sides. So we get k equals plus or minus 10. So in order for this to happen, in order for 32 to have one real solution, you've got two situations happening here. We could either have 5x squared plus 10x plus 5, or you can have 5x squared minus 10x plus 5. That k value can either be positive or negative. Both of those will work. So for 33, same idea, 3x squared plus 12x plus k, but now they want two real solutions. So what that means is your discriminant has to be positive. It doesn't matter what the number is, just has to be positive. But what does that k value have to be in order for that number to be positive? That's what we got to find out. All right, so if we take a look at 33, 3x squared plus 12x plus k. Equal to 0. We can start setting this up. So we know the discriminant has to be positive. We don't care what the number is. It could be 0.1, it could be 10, it could be 5,000. As long as it's positive, we're good. So in this type of situation, we're going to deal with like inequality signs, greater than, less than, equal to, things like that. So our a value is 3, our b value is 12, and we don't know what that c value needs to be in order to satisfy this equation. But we know that our discriminant is going to be b squared minus 4 times a times, again, c is k. We just need that number, whatever that is, just has to be greater than 0. It doesn't matter what it is, as long as it's greater than 0. So let's start kind of picking this apart. 12 squared is 144. -4 times 3 is -12. So we have 144 minus 12k is greater than 0. If we solve this, inequalities are a lot like equations. You're going to kind of do the same kind of steps, but I think we're going to actually see a step here at the very end that's very unique when it comes to inequalities. So I'm going to go ahead and solve for k. So I'll subtract 144 from both sides. So I'll have -12k is greater than -144. And then to solve, just like if it was an equation, I would have to divide both sides by -12. But here's that thing that's kind of unique here. When I divide or multiply both sides of an inequality by a negative, that sign has to flip. So watch what happens. -12 divided by -12, that just simplifies out, so I'm left with k. That greater than sign is actually going to flip. Because I'm dividing by -12, or you could be multiplying, because I'm dividing by -12, it flips my sign. It becomes less than. -144 divided by -12 is +12. So what this is telling me that I will have two solutions. I will have two x-intercepts as long as that k value is less than 12. It doesn't matter. It could be 11. It could be 11.999. It could be 0. It could be -500, as long as it's less than 12. So that's my rule. Last one, 34, kx squared minus 3x plus 4. Kx squared minus 3x plus 4. I think that was equal to 0. They, again, want two real solutions. So this is going to be another inequality type of problem. It's going to be when that discriminant is greater than 0. So if I set this up, b squared minus 4 times a times c. And again, I need that greater than 0. Specifically greater than. It can't be equal to it, because when it's equal to it, you only have one x-intercept. -3 squared is 9. -4 times k times -4. I'm going to go ahead and write this out because I already started writing it. What I wanted to write is -4 times 4 is -16. And now we just have an inequality, so I can go ahead and solve this. Subtract 9 from both sides. Divide both sides by that leading coefficient. Just remember that when I divide or multiply by a negative, that sign's going to flip. So it's going to become k is less than. Negative divided by a negative is a positive. Can I simplify 9/16? I don't think so. So it's going to stay 9/16. So what this means is for number 34, as long as that k value, that leading coefficient, the coefficient in front of x squared, as long as that value is less than 9/16, you'll be good to go. You'll have two x-intercepts.